Yeah. Recording in progress. Well, hi everyone. It's our a little anatomy show again, and I'm wondering if anyone of you would like to set a group intention for this evening's class. Not, I will do one. I don't see any volunteers, so I guess I will go ahead and do that. But feel free to do it next week. So I'm going to close my eyelids and find the most loving place I can inside of me. And I'm so grateful for the presence of the highest God, the greatest loving, Mother, Father, God, the whole Spirit. And we ask only that which is for the highest good for each one here to take place. And anything of a negative nature that can be released or resolved or dissolved, be taken down into the earth, put to bed, neutralized, laid to rest in the Mother Earth, or taken up into the heart of God, up, 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 and away. And for being together in peace and harmony and learning, I give my thanks, and so be it. So, show and tell. Anybody have any anatomy topics they want to talk about or raise or have covered in the future? Don't all talk at once.
I will show you. Um, I showed Michelle and Hannah last week when we were here, but I just got a new book in the mail. So it's Anatomy and Physiology for Midwives. And that's because this is what I've been writing about the development of energetic structures in utero for this conference. But the class that I'm working on right now is on fertility and pregnancy and working with that with kinesiology. And it takes a really long time to get stuff here. So I ordered this a while ago and I just got it and I've been geeking out on it since it got here. So this is just me sharing the anatomy that I'm reading right now.
Alexis, did I send you the PDF I have of from Springer of in utero psychology?
I think so. I think because you sent me when the last issue of Kinesio Geek magazine that we ran was on working with holistic pregnancy, because that's when I
Yeah,
was
yeah,
starting
I
to get
have.
into it, and you sent me some interesting stuff around that.
Yeah, for the rest of you, there is a doc. Is one paper in this expensive Springer book from Germany that is the psychology of in utero, and the one that I remember is that when the egg comes down the fallopian tubes and into the womb, there's kind of a crisis. And the crisis is, will it be easy for the egg to implant itself in the wall of the womb, or will it be difficult? And if it's difficult, there's a lot of issues that people like us who work with energy find show up later in life. Not being able to find your place, not having a home. There's a book about this that I would say called Home for a Bunny. It's a children's book, Home for a Bunny. That's about needing a place to implant. I need a place that's safe to implant and healthy to implant. And there's a bunch of other issues like that. It's not a long article either. It's not too technical, but it's a list of these issues that if somebody is stuck in their in utero development, you can go through this list and say, was it this? Oh my gosh, it's this one. So it's very interesting. So if you're interested in that, send me an email and I will dig it up again, or um, Alexis has it too, if you can remember what it's called. But I have a whole file of that, Emerson, William Emerson stuff and related uh, world. Um, yeah. Anything else I want to say about that? Yeah, there's a really good book. Hold on, I think I got it right here. What am I do with it? Famous. a famous book. I'm going to tear the place apart if I start now. There's a famous book from the 90s about prenatal and perinatal development. And it's got like 1,000 illustrations. It's amazing. Easy to, they're line drawings, but they're small and they're very clear. And let me make a note. You probably already have it, but the rest of you might not. It's the blue book. The blue book. Pre and perinatal. It's not quite my area, but it will certainly be relevant to what Alexis is talking about. So other than thyroid, any other topics that people want covered? Otherwise, I'm just going to, no, I'll tell you what I'm up to. Tonight, we're going to do the neurons, which is kind of related to the brain, I think. And then we're going to go to, trying to find my own notes here. The neurons, and then downshifting, which is going to be related to switching, which comes last. After downshifting, we'll talk about midlines, which has a bunch of interesting ramifications. And then probably next week or the week after, whichever how long it takes, I've got it already prepared, we'll go into switching, which got inspired by Charles Krebs' 2005 article on switching, which took me like 10 years to finally read because it's very technical. It's not written that well, but it's heartfelt. It's heartfelt in his analytical way, and he's trying to help. And it's full of the old kind of 1970s, 1980s Touch for Health lingo. So we now know quite a bit more to kind of synthesize Krebs's picture into a larger picture of what switching is and how it operates and the whole thing. So that's what I spent a lot of the last 2 weeks on. And I'm really happy with what I came up with. So that'd be good. And then we'll do leaky gut syndrome, because I think it was Michelle wanted that, and thyroid. And then I don't know what we'll do after that. We'll think of something. But your input is valued. Your input is valued. So any other comments before I share my screen here?
I guess I would, when you cover thyroid, maybe this is a different one, but the whole endocrine system is, boy, am I finding that. And the vagus nerve, I'm finding that with a lot of people. So we did the neurological, and I guess that sort of covers some of it. But anyway, it's just like everybody's vagus nerve is screaming here in the States. So just putting that out there.
Uh-oh, we've lost Bruce. We'll pause for a second.
Okay. All right, so we've talked a fair amount about the brain, and but we're not done yet. Just lost my back support here. I like this picture here because this is a really clear picture of the folds. And I think you can really see their architecture this way. I think that makes it bigger for you. Makes it bigger for somebody. And you can see the names here. And of course, you'll know that the reason it's folded is that increases the surface area over just a basketball shape. And make sure I'm on the right thing here. Yeah, we talked about that. So we have the names, and so more folds can fit inside the skull when it's folded than when it's flat. So these slides are going to go pretty quickly because a lot of the stuff you know also. We're not going to talk about ADHD, but here's a really good slide that kind of shows you the headline thing, that apparently, according to research, the big headline for people who are diagnosed with ADHD is that the brain is smaller. It's literally smaller. And so that's one problem you can have that I'm not sure if it's an anatomical question or not, but it's certainly a comparative anatomy topic. And another thing we're not going to talk about tonight is dyslexia. And here's a picture of your brain with and without dyslexia. And you can see that with the dyslexic person, that they kind of get fixated on the mechanism of phonics and word analysis. They get fixated on it, often due to teachers pushing them to focus on that, thinking that's the solution. But what's really healthy is to have more participation from more parts of the brain in problems with reading and speaking as well. So we're not going to talk much about dyslexia either. And any questions on that so far? Otherwise, we're going to keep moving here. So what I want to talk about mostly is functions. And to talk about functions, we have to start with some of the naming. And so here's the simplest picture that I thought was really good introduction for how to start this kind of thing going. So each of the hemispheres is divided into 4 lobes, and the male left brain namers in the 1800s named these frontal, parietal, temporal, and occipital. The names are only good for mapping. Labels can distract our attention. The labels and the names only indirectly aid our empathic awareness. So what we're going towards is both the names and the empathic awareness. That's a whole brain approach. So we have more functions here. We're going more into functions here. So I'll give you a moment to look this over. This says it better than I can. This is showing you where some functions come from in the brain. And if there's no questions on that, here's a similar picture, which has more detail. We're going to see some more detail. But these are the names. These are the names. I don't do as much brain work as probably Alexis does. So I haven't had much experience with working with brain parts the way you would if I was trained in LEAP or crossinology. And I work with a different system when I work with the brain. And then here's a really artistic picture of functions. And these slides will be in the PDF I'll send you in case any of these are useful to you. Because some of these I think could be useful. And I'd like to say also that, say I had a client who had a problem with taste, like an elderly client who's losing their sense of taste. I would be inclined to try and talk to this part of the brain and to ask it if it needs support and ask it if it's stuck at an earlier age, if it's regressed to an earlier age. And that's the kind of thing I would do. I'm sure there's other things you can do as well. Another picture of functions coming up. So this shows a little more detail. Here's a pretty good picture of the Broca's area, which you hear a lot about, and a kind of a better schematic of how the meanings of words come from back here. Perceptions and memories interface here, and word recognition is here. So we're going to talk more about this, about which brain parts do which thing. And one last picture of brain parts and functions. I hadn't seen this picture before. I thought this was quite interesting. And it says on the right here that children with the biggest ratio of left to right planum temporale are better on language tests. So you can see that the left one here is bigger than the right, and that's the healthy way to have it. And I had not seen that this clearly before, so I found that quite interesting. And what I want to know now is if any one of you would like a more verbal description of different parts of the brain, the functions assigned to each named part of the brain. Otherwise, it's here, it'll be here in the notes that I circulate. And I suspect that a lot of you have seen this multiple times. Does anybody want me to go through this verbally now? I think it's just as easy to look at in the notes. But there's also slides I'm not going to show you. And some of these slides will also go with, there'll be both text and slides that I'm not going over in the class that will have more information on the named brain parts and which functions are attributed to go where. But I don't think that's the most interesting issue. That's kind of, everybody learns that who learns about the brain. And that's it for brain function slides and talking. Any questions on that? Otherwise, we're going on to our next slideshow here, which is about neurons. Okay, so I'm going to close out of this. I'm going to try anyway. Let's save it, I guess. And let's see if I can get this going. Ah, good. So it came back to this. That's good. Now I get the neurons open. Close this. And there's the neurons. Back to share. Share screen. And I think are you?
Bruce, you're once again sharing your whole screen, not just the slides.
Thank you. That's what I was trying to learn. Where's my, here we go. Share screen. There we go. So there's those guys. Move this out of the way. Okay. Get this up. All right. All right. So this picture here is, I think, the clearest way to picture neurons. It's not all that accurate. It's a simplified picture, but I do think it's the most useful picture, the most useful way to visualize this. So you can see that there are kind of nodes here and that they're part of a network, which is three-dimensional, which is very similar to a hologram. And this dark object here, which is the neuron here at the moment, I guess he's asleep or something, allows us to move our muscles, feel the external world, and form memories and much more. So that's still kind of a simplified picture. Here's a more accurate picture. And you can see that that dark area, which is now this area right here, is kind of going off in all directions. Or we might say it's highly networked with many other parts of the brain. And this is the point of it, that it's highly networked. And we're going to talk about why this is and how this is a bit. But even this is not really, even this is a simplification of what's really true physically in anatomy. So the next slide will show you how complex it really gets. So here's that same neuron, so to speak, on a slide, not in the brain, but on a slide. So it's been taken out of the brain, and now we're just looking at it on a flat surface, not three-dimensional anymore. But you can see that there's all these connections that if they were three-dimensional, would be a terrific network, a terrific network. And that's what our neurons are about, a terrific network. So that's the complexity of it. Now we're going to go back to the simplicity. So there are different kinds of neurons, and here's 4 different kinds. And you can see they have both similarities and differences, and that's good. And I have another picture that's related to that. And you can see that different people have different conceptions of the neurons. There may be hundreds of different kinds of neurons. So it's not like we just have 5 or 6. There could be hundreds. So they're quite varied, quite varied. And they have some things in common. And one of them is the axon, which is this kind of conduit thing. And the axon is exactly analogous to the cord that runs from your lamp to the wall socket, and the copper wires are coated with rubber or plastic. It's exactly analogous to that. It's not different at all. And the insulating material is the myelin. And we're going to have a short conversation about muscular dystrophy here in the upcoming slide. Any questions yet about axons and neurons so far?
I just have a question. That interesting how the myelin sheath is a piece, and then it, in other words, it's instead of just a smooth thing, I always thought it was, it's a piece, another piece, another piece.
Yeah, there are many pictures. You're right, Lisa. There's many pictures online about what those spaces are about, those gaps. I think the simple answer might be circulation or release of wastes. So there's a reason that they're kind of segmented like that. There is a reason. You're right about that. But the anatomy of it is very complicated, though. And I'm going to show you if you want to see that. I'm going to give you a link to see that. So I like this picture. This makes it really clear what the axons are doing. So there's these neurons, and they're in this huge network, and these are how they talk to each other. So they basically have this one has a little tin can, and this one has a little tin can, and there's a little string that goes between the tin cans so they can talk to each other. It's just like that. Now, when we go to the white matter, things get even more complicated. And there's lots of pictures of these, which are quite interesting. And here's the microglia, which make up a lot of the white matter. But it gets very complicated very quickly. And I want to talk about why that is. Yeah, I'll put this in the chat also. There is a very lively technical discussion of, I'm not sure I can put it in the chat yet. It's definitely going to be in the notes, of neurons in the white matter. And the guy is lively. He's a young guy. He wears a baseball cap on backwards, and he draws these pretty good pictures of all sorts of very, very small structures in the membranes in the white matter, and how things are moving. It makes it very clear what's happening. I'm not sure who he's talking to. He might be talking to brain surgeons, but it's a very lively talk and not stuffy at all. So I put that in the thing there, and if you watch it at all, you'll see it's like, you just get lost, unless you're an active surgeon and you have a huge amount of background, you get lost in about 5 minutes. And we're going to talk about why that is a bit. So because it is complicated, let's go back to a simpler schematic. And all of you will have seen this at some point in your life, probably in high school. So this is a schematic of if the things are coming out of the neuron, or from one neuron to another. And so there's the pictures like we've seen before in the earlier things of the brain where there's the neurotransmitters going across that gap from one neuron to the other, across the synapse to the other one. And there, one neuron can in that way excite another and get things done. Nothing new there for us, I think. And over here, this is where we want to talk about the afferent and efferent, which is kind of a big topic, which let's at least say something about here. What is here? Yeah. So the somatic, and 9. This is 9, right? 9, 10. The somatic reflexes. I think I'm supposed to be on this slide. The somatic reflexes stimulate the skeletal muscles, such as when you quickly pull your hand away from a hot object. If you pull your hand away quickly, it means your somatic reflex arc is working. Or in this case, if you want an apple, you see an apple, there is an apple, and you reach for it, then the somatic reflex arc is working. That's good. But what's also true here is that this is the model Dr. Frankenstein and later robotics engineers used. It's a left brain model of observed phenomena. One part, one function. It's based on that assumption, which is related to what I call the car engine model. You have a carburetor, it has one function, it does that. You have the starter, has one function, it does that. You have the pistons, they have one function, they do that. And that does work below the diaphragm in our digestive organs. One part, one function. But above the diaphragm, and especially above the neck, it all gets, it very quickly becomes one part many functions and one part multiple functions. And I want to get into that more here. Now, here, as we're looking at Dr. Frankenstein's picture here, how do we know for sure that how we move our muscles is more mysterious than this? How do we know this absolutely for sure? We've done this before, so I'm asking if anybody remembers.
Because it's too fast.
Exactly. Hannah's got it. It's exactly right. You can't see me at the moment, but you might remember that in earlier classes, I held up my hand with my fingers outstretched. I said, okay, hand, make a fist, and nothing happens. And then I want to make a fist and I make it, and the words aren't that important. So the possibility that I can make and unmake a fist without thinking about it tells us not that this picture is wrong, but that there's also mysterious elements to this phenomena. And that Dr. Frankenstein and thinking this is all that happens, or robotics people thinking this is all that happens, are not correct. Any questions? Here's my afferent stuff. Now here's a really good picture to talk about afferent. So the sensory is afferent, meaning that stuff is coming this way, coming into the neurology. Hey, where do you move around from? Stuff is coming in from the senses to the neurology. It's moving around. It's supposed to be red there. And efferent is stuff moving out from the nerves towards the muscles. So this is the afferent, this is the efferent. But what I like here is that it shows that there's a reflex arc, so to speak, but it also suggests that this is a much more of a unified system than Dr. Frankenstein was thinking, and these people were thinking that, oh yeah, well, it's just, you see an apple and you pick it up and that's it. So all I have to do is make a robot do that. Over here, it's saying, no, That's true, but there's also, they're highly connected. And it's not so clear that impulses can't run both ways. Now here it's definitely saying they only run one way. This is run one way and this is that way. But you can see that these are highly related. And what they say that I read last week is that in the spine, that the nerves are more separated about afferent and efferent. But in the brain, they are not. So they don't talk so much about afferent and efferent in the brain. They only talk about it in the spine, in the spinal nerves. Why is that? It's probably because of all those electronic images that they have of people with electrodes on their head, you know, touching hot stoves and picking up apples. And then the scientists looking at the brain imaging and seeing which parts of the brain light up, and they see all sorts of parts lighting up. They say, well, I don't know what's happening, but all sorts of stuff is happening. So this is towards the one function, many parts, or one part, many functions, one part, many functions. So why is that? It raises that question. Raises that question. Where was that? This raises the question, how would neurons in the lower part of the body be more one part, one function, neurons such as in our gut brain, and neurons in our head brain are one part, many functions? Why would that be? Well, it doesn't have to remain a mystery. And if you go way back to the 1800s and you start looking at the chakra system, and you remember that this is a musical scale, or maybe it's a spiral scale, yeah, from lower frequency to upper frequency, which is what I prefer. Then we have down here on the lower frequency, it makes more sense that it's one part, one function. That's a lower form of intelligence. And up here in the head, we have a higher frequency and a higher intelligence, closer to oneness of one part, many functions, one part, multiple functions. And we could, if we wanted to, put a DNA on top of this spiral and reinforce this idea that as we go up in the body, that not only the frequency goes up, but the frequency of intelligence goes up, and we go from basically, you know, part to whole down here to whole to part up here. So part to whole is car engines. You know, you get a carburetor, you get an engine block, you get tires, you get a steering wheel, you put it together, you make a car. But up here, it doesn't work that way. You have to picture the whole car first, the whole Tesla, and then you look from the whole which parts you're going to get to assemble to make what you want. But down here, you work up from the parts. Here, you work down from the parts. So that's true for us in a holistic kind of way. And then here's another picture of that. So this is from laughter yoga. It's something I made a few years ago. So laughter yoga uses the 4 laughs, and they relate to below the belly button, which is what this is, right above the belly button, level of the heart, and from the neck up. And these are also frequency zones. And so this is why the neurons lower in the body are more one part, one function, and the neurons in the upper, in the head are one part, multiple functions. Any questions? So maybe that was even familiar to you. So in the slides I'll circulate, there are more slides here with some pretty pictures and some useful pictures that you might enjoy. And unless there's more questions, I'm going to move on to the next slideshow. This is a multiple slideshow extravaganza. If I can get these things. I don't know why it does that. Down, back over here. here. And now I talk about downshift. So I'm going to open up downshift, go back to this, go over here, go to share, and got it? Yeah. Okay. And then here's, so, let's get rid of this. And gotta get one more thing out here. And put this down. No, you go away. Can you go away? Here, you can go away. All right. All right. So you can see where we're going here. I would call this the horizontal midline. This one is the right-left midline, sagittal plane, right-left midline. And this one, the coronal plane, is the front and back midline. And those terms will be important when we come to switching. And so how many midlines does our body have in this system? So we have 3. If anybody can't see that there's 3, please let me know. Because I guess you can't see me, so I can't wave at the screen. So we have 3 midlines. Now, what else is interesting here is that medial is towards the middle, which usually you see in this plane. So like on this part of the leg, this is kind of the lateral towards one side. And this side here on the inside is the medial towards the middle. And these terms are really quite useful, especially when you're talking to clients on the phone. Sometimes it helps. Sometimes you wish they knew that system. Ventral is towards the front, and this becomes an important term when we talk about the ventral vagal system. And the ventral vagal is not down here, apparently. The ventral vagal is up here at the level of the thymus. And we will get more into that. The dorsal vagal is down here below the diaphragm, but not below the midline, or not as far as I can tell, and on the back. On the back. So ventral vagal here, dorsal vagal in back over here. So what I want to leave you with on this slide is that there's 3 midlines. 3 midlines. Now, here we are back to head brain and gut brain. Okay. And the midline is in here somewhere, right? Must be, right? And I guess I want to go back to this slide. Let's go back to this slide. Let's look at the head here. So you'll notice that the right and left hemispheres follow the sagittal plane division. And even though we don't have anatomy that follows the coronal plane division, because it's imaginary, we have a few pioneers who have done very creative, useful work with the 4 quadrants of the brain. And the best known of these is Ned Herrmann, Herrmann. And he'll be in the notes, you can look him up. It's kind of a deep topic, and you may or may not be interested. But there is wisdom in this idea of brain quadrants. And it starts with this idea of planes and midlines, and 2 midlines in the head. And then we come back over here, and we have the head brain and the gut brain. And what I want to say here is that if you imagine yourself as your own internal neurology, and I call it the internal neurology self, And you have to access other parts of the whole neurology across 3 midlines. Can you imagine that it's possible to make errors in accessing across those midlines? And of course, the answer is yes. It's possible to make errors. And the famous pathology where this happens, and there's a lot mysterious about this, of course, is the phenomenon of the phantom limb pain. So phantom limb pain can only be understood, in my mind, by accepting the reality of our etheric body and the meridians embedded in it. And if you don't understand the meridians and how they kind of go on independent of the physical body, it's very hard to treat phantom limb pain. Very hard not knowing that. Any questions? Okay. Here's a picture you might have seen from heart math. Now, one of the questions that this raises to me is, if this is such an accurate image, how come we don't see it more often? It kind of came and went in the 80s and the 90s when heart math was a bigger deal. But I think it's likely that some people are organized like this, or that all of us are organized like this somewhat. But probably very few people are organized exactly like this. What else is interesting here is that the heart is not at the midline. Again, midline would be here, and up here is more thymus, more ventral vagal. So very interesting to talk about the heart, the pericardium, the thymus, the ventral vagal, and who's doing what there, and which part needs help if you have an issue in that area. But that's at least the ballpark of that. Now we're going to have some fun here. So what's this? So I want someone to tell me what they think this is.
That's a tree and its reflection in the lake.
Oh, okay. All right. So is this photo right side up or upside down? How do you know? And how would you know? It's not so easy to see, and this is partly a blurry picture. So I'm going to spell it out for you a bit. This picture is actually upside down. So this is the reflection. This is the real one. How do I know that? If you look here on the detail on these trees, you see there's more detail here. And here everything just kind of becomes black. The same thing happens over here. More detail, and here it's just black. And also this black here. I think this has to do with the refraction of light in the water, and it's not evident here in the sky. So the picture is upside down. So even people like us can make an error in determining top and bottom across the midline. Yeah? So midline errors, top and bottom, are more common than you might think. And, oops, what's this? Don't all speak at once. I am trying to fool you, though. So what do you think it is?
Well, I'll say it's a tree with a reflection in the lake.
Okay, this is not a reflection. This appears to be 2 consecutive photographs placed bottom to bottom. So there's no reflection, there's no water. I think they're 2 consecutive photographs. Why do I think they're 2 consecutive photographs and not 2 identical photographs? If you look right about here, you notice that this is a little different from up here. It's a little different, not much. It's not even different here, but it's a little different over here, a little different, maybe. And so I think it's two photographs taken like, and the clouds were still moving. But this is not a reflection. It's two things top and two pictures put bottom to bottom. So what's the point? The point is even people as smart as you and I can make errors in crossing the midline and getting confused about where the midline is and how to determine where the midline is. This gets much more complicated, which we're not going to go into, but I think it gets real complicated. Maybe I'll mention it at the end here. Okay, we got a couple more of these. And what's this? Why is this picture different?
Well, I'll venture that the top is much clearer, and therefore the bottom is a reflection.
I see. Okay. Well,
You're wrong again.
Yes, wrong again. This is a photograph cut into quarters. Whoop. Stop moving around there. Go back. Cut into quarters. Here's the midline. You have to follow the midline. So this is the real picture here on this side, this quarter. And then 3 more copies were made of this quarter and put around here to imitate a kaleidoscope. The only real part of this is one of these quadrants. There's no guarantee there's any water at all. There might be water, there might not be. And the graying out here, which fooled Lisa into thinking this is water here, is just done photographically with Photoshop. Yeah. Okay. Nothing more to be learned from this except we can be fooled, and crossing the midline is not as easy. See, everybody thinks, and even in kinesiology, we were taught, oh, cross the midline. Oh, it's okay. So the right brain crosses over here, the right eye, goes to the left brain, blah, blah, blah. Ah, it's just like that. Nothing to it, right? But nope, it's much more complicated than that. And errors can be made. Errors were made. Okay. And now this is two kaleidoscope images. And the question is, how could you tell which part of, say, this picture, I think this picture is easier, which part is the real image? How would you know which part of this image is real and which is just reflections? How would you know? There is a way to know.
I would say that the two in the center to me look flat, and the ones around it are distorted to some degree.
Yeah, I kind of agree. But I think accurate as Lisa is, I think the thing to be learned here is that you can determine the real part of this image by looking for midlines and following the midlines. And so I believe there's a midline here, which you see reflected here, and also one here, and also one here, maybe. But typically, if you look at a lot of kaleidoscope images, the part that's real is triangular, because the kaleidoscope has a triangular set of 3 mirrors, which I don't think I can show you because I'm not on the video. So just the triangular part is real, unless this is also doctored in other ways. Because it might be that the midline is here and here and here and here. And then maybe there's more artistic stuff done there. So this may have a lot of Photoshop work done. But what we can say from this in terms of midlines is sometimes we just can't tell where the midline is. Sometimes it's very hard to tell. And that is why this remains a significant image. Where's the midline? Well, I don't know exactly. I'm not sure. It could be a lot of places. And that's an issue. Now, what's this?
Okay, I'll say this is a tree. And those are its roots with potatoes growing off of them.
Yeah, they're probably nodules of nitrogen or something like that. But yeah, and really, I just put this in here to show you that this is a reflection. It's not literally a reflection, but if you go to the archetypal level of the plant, don't all plants that grow in the ground have this kind of reflective structure. Up here, the leaves and the branches going up towards the sun, and here the roots going towards nourishment, the water. They kind of reflect each other top and bottom. Is that happening here? I don't know. Maybe. Now here's another part thing here. So what I say here is that puberty is our single greatest experience of neuroplasticity. So I need to ask another question. Does anybody know what the locus of control is in people? Does anybody know what that refers to? It's anatomy. So it's probably fair to ask in this class. Locus of control. Anybody want to guess what that is?
I've usually heard that referred to where your seat of motivation is, whether it's an internal locus of control or external. I haven't heard of it in terms of anatomy.
Yeah. Alexis is right. However, prior to puberty, and probably easier to see prior to age 9 and younger, our locus of control, what Alexis said, the motivation, is coming from the enteric gut brain, more so than not. Not 100%, more so than not. And the logic for that has to do with how we build and develop self-esteem in our younger years. And then after puberty, on the other side of this mirror, the locus of control shifts up to the cerebral nervous system and the spinal nerves. And so there's a reversal of learning style at puberty that we've all gone through, and that is the biggest demonstration of neuroplasticity that I think any of us are likely to experience. Nothing was more impactful than that. Any questions? Yeah,
So,
no questions? Yeah.
Yeah, I have a question. So, we often say that people are not totally mature until they're 25. So it starts to shift at, 15 or whatever. And then it completes the shift by, say, 25.
So to speak. Yeah, I don't contest that at all. What we're experiencing more now since 2000 is that puberty is taking longer and longer for a lot of kids. It's starting earlier and taking longer. That's not a good sign. Neither of those are good signs. Those are both pathologies.
Yeah, that's scary.
And the only people who are kind of, making the world safe to have puberty at the right age and complete it at the right age are the Waldorf people. If there's other people, I would love to hear about them. Not many other people are even working on that. So that's an interesting thing. So this is a relevant thing to know. This topic has most relevance to curriculum, because if you teach in a way so that this 3-year-old can be grounded in her own neurology and build her self-esteem, so that then later at puberty, she has a foundation to build on, where she then builds her healthy self-concept in her upper nervous system. So that's some of how that goes together. I have a lot written on that, but for anatomy class, that's where I'm kind of drawing the line on that. Now I'm going to play another trick on you here. What's this? Could this be two different neurologies? Could this be a midline? I wonder if it has anything to do with this. So what's this? What's he doing? What's he demonstrating?
He's the analytical, and they are the limbic system.
You're in the right ballpark for sure. So these are British people. And of course, the guy on top is demonstrating the stiff upper lip of the cerebral nervous system. Don't cry. Big boys don't cry. And down here, we have the Goon Show, not Monty Python, similar to Monty Python. These are the precursors of Monty Python. The Goon Show, but these people are exactly the same time as the early Mad Magazine comic book in the United States, which if you have never seen, I do encourage you to take a look at. It's all online. It's very available. The early Mad Magazine comic books. And this is Peter Sellers, who you probably all know. So in the British psyche, in the British hourglass, we have the stiff upper lip up here. Now that's a caricature of their pathology. It's nothing more than that. And down here we have the Goon Show, which is a caricature of their pathology, right? And then what's this? Who's this? Stiff upper lip man, right? British stiff upper lip, right? Who's this? No, you don't know who this is? This is Benny Hill. Do any of you know who Benny Hill is? Yeah, Benny Hill was a famous post-war comedian who then became even more famous on television. And he was on the BBC for like 30 years doing very childish stuff that was also kind of sexist. You can see here, he's really looking at her boobs. That's part of what he's doing. And over here, you see that when it comes down to it, he really can't handle all these women. And he goes up into his nice little boy part. Nice little safe boy, non-sexual boy. So this is the up and down of the, in caricature, of the British psychology. Much easier to see in Britain than in the United States. So what's the healing to go across all these, we're almost at the end here. What's the best category of healing methods to help our neurology cross its three midlines? You all know the answer to this. This, even simpler than that, is movement. Movement is the healing. Movement. I've had the pleasure of reading through a bunch of brain gym journals recently because I got in contact with Gail Dennison. She wrote back to me and she sent me a bunch of brain gym journals to look at. And now I know where they are online. All the research says something really simple, that movement is what infants and children, especially prior to age 9, need to develop their neurology and get grounded. And so movement is the healing thing. So what kind of movement? I think what's best for people, I think brain gym is fine. I don't think it's the best. And I do think that the BAVX ball bouncing is a lot better than brain gym. And I do think that the Waldorf copper rod, bean bags and copper rods are better than BAVX. So there's discussion about these methods. But basically, any movement is better than no movement. Now, what they're doing here is they're trading balls here, bouncing them on the floor, and they're using the sound it makes on the floor to navigate this rhythmic activity. And so is he. All three of them are using the sound to navigate. That's a big part of it. So the reason that this kind of movement is so effective for helping our neurology is that it forces them to coordinate sound, sight, movement, rhythm, everything, hearing, everything gets coordinated. And of course, you can exaggerate that if you do the whole brain turn-on exercise, which I will have a link here in the notes that I'll circulate. And that is the end of my talk about the midline. Oh, we didn't even get to downshifting, did we? We got to that. Any questions? And I think we've gone for most of an hour. Oh, and I didn't put in my, I wonder if I can put this in. Good. I found some really nice things. I'm just wasting time here now. I have a really nice, oh, here's one. Open this up and share my screen, stop sharing, and get this picture up. Yeah, and go back here. So here's my final slide for the evening. How does that strike you? This doesn't have anything to do with midlines. It's just an embodied woman, an embodied woman. This is my thank you for your attention slide.
She could be here in our waterfall.
Yeah. But anyway, I had fun doing this because I really felt like I got a fairly good handle on how to integrate anatomy and neurology with the issues that would come up against in treating people. And so I thought they went together pretty good. And we'll see more of that next week whenever we do this on switching, on downshifting and neurology. Same thing will happen again.
Well, that was one of the things that really excited me about taking this course, is it's all in the context of what we do. And therefore it has so much more relevance than just, anatomy. By itself, you could, I have lots of anatomy books, but I love the connection with our work here, kinesiology.
Right. Yeah. Well, I'm honored to be able to serve that need. That's a real need. A real need. I don't know anyone else teaching anatomy like this. It's been fun to figure out how to do it. Yeah, and I'm sure it can be improved.
I'm looking at your slide with the ball bouncing game, and as you were showing it, I was thinking like all of those really I mean, they were old-fashioned games when I was a kid, so they're absolutely obsolete now. Those games that we used to play at recess, like jumping rope, right? Or playing jack or hopscotch. Those all have that similarity in that it is that rhythmic, coordinated movement with sight, with the sound, and usually there's a rhyme or a song or something that goes along with it. And, as an adult who does this work now, I'm going, oh, yeah, that's so important for your brain. I mean, that's a full integration workout. And kids don't play games like that anymore. Um, so, yeah, it's very important.
Yeah, they do in the Waldorf school. That's where that legacy is kind of being carried forward. But everyone else is kind of, watching screens. Oh well, we'll get it together eventually. It may take a while though.
All right.
Well, we're very much, I'm just going to say we're very much needed. Things are getting worse. They're not getting better in terms of screen time and kids and all of that. And I'm just grateful to be in the work I'm doing because they're going to need help.
Do you see kids as clients?
Oh yeah, definitely. Half of mine are kids, and then I want their moms to be part of it too. So, and often comes the whole family because they all need it. But just such a difference, with kids today, and as I was saying before, the neurology effects of what's going on in the world. It's just phenomenal. So it's really destructive.
Yeah. Well, they have to be curious. So in the notes I'll circulate, there's links to a bunch of stuff. If they get curious, there's quite a bit of material out there. You have to look for it, but it is there. And if anyone needs material, feel free to ask me because I've looked in a lot of places and I know where some of this stuff is.
All right. Shall I turn off the recording for tonight?
Sure. Sure.
All right. Thank you.